in January 2024, a group of geologists from Smith College in Massachusetts and Hartwick College in New York, USA, was conducting reconnaissance fieldwork on Turks and Caicos for their project entitled Fossilised Ecosystems of the Last Interglacial Time Period from Pleistocene, about 125,000 years old, carbonate rocks on Turks and Caicos Islands. The geologists took 3 teachers and 7 students from Clement, Howell, and Louise Garland Thomas High Schools. I was one of those teachers, and this is the field trip from my point of view.
So here we are at the start of our trip, and no road trip in the Caribbean is a road trip without prayers for journeying mercies.
Amen. Alright, Sir Jacobs. Machine. Alright, so yeah, first part of the journey. So we have successfully brought all the students together, and we're heading off to Clement now. Soon log in again. Check. Yeah, I know we're late, but kids them said them never eat any breakfast and them never carry any snack. So we'll take a one-stop African shop. Yeah. If you're in the DCI, you must know African shop. This is African shop, Blue Hills. So Clement is just around the corner. So we'll soon make up by this time. Yes, this is the Osita Jolly, for those who never see this road before. And this is the Clement Howell.
That's what it is. I assume that's them.
Awesome. Just a minute, we'll get going. You'll follow us. Geology at Smith College in Massachusetts. We have Professor David Griffing with us today, so go ahead and introduce yourself.
You can call me Griff, it's easier.
Blessing.
Professor of Geology at Hartwick College.
arrived to the island yesterday afternoon, so this is her first day. So she hasn't been here either, so we give an introduction for her. And Dillon is a student of mine. Go ahead and introduce yourself.
Hi, I'm Dillon. I'm a junior geology and Spanish major at College.
And Dillon has been traveling.
Tiny little circle web things, as well as one right there. One there. Whoop, and the wind just went away. More. Those are an actual animal, well, an organism. That way. It's an organism. It's called a foraminifera. Big word. Like another biology big word, right? Well, since it doesn't roll right off the tongue very well to talk to other geologists
All right, I said before, the wind. Yeah, I didn't predict that the wind would destroy the audio so much. So let me tell you basically a synopsis of what we did on this field trip. And at times when the audio is a little better, I'll let you hear what the professors have to say. So we aside from did a lot of walking, we explored sediment on the Monard Beach and dune depositional environments. Then we went on the other side and took samples, and we tried to identify the different types of coral that were found there washed up onto the shore. After that, we observed the waves breaking on the crest of the living coral reef in the shallow water. We analyzed some of the other features, like for example, why is it that the coral on this side seems to be brown in color? The limestone is normally white. The professors told us that some of these brown colorations were due to the Sahara dust traveling all the way from Western Africa coming into our Caribbean region. Alright, so I'll check in another time with some more information.
idea of what, and to see the products of the past, the rocks of the past. Living on the surface here and using this porous rock gets wet, and those will probably become a little bit whiter portions are probably white because even though that's got the algae in there and some other portions rough waterways up and down, hitting against the rock, sand running on it, so it's got polished those.
You think that could it possibly be like copper or cobalt or any that sharp blue color? No?
No, I think it's primarily
Just a green change to blue over time.
well, it's not all green algae, that's the thing.
Oh.
Some of these are brown algae.
Oh, like spirulina.
Yeah.
This is blue green.
Sure. Well, yeah, there's
Okay.
that as well. It might, if, once it's plant, a lot of these things, like you were talking about spirulina, they sometimes call people. part of a conch shell, right? So you'll see with coral. So like
This is formed too. A lot of
beyond
that.
that, you can see a lot of bits of coral between the patterns. And what I want you folks to do, I want every student to look through here and pick out 3 different pieces. Doesn't have to be big, doesn't have to be small. But 3 different pieces of coral that have different patterns, distinctly different size, holes, or patterns, grooves, anything like that. Try to do kind of a rough reef census of what's growing out there, because chances are we're going to know, the stuff that's growing out there is going to eventually end up, some of it, right here on the beach. Stuff that can.
Okay, we should get paper out and then we'll like do ID and sorting
Yeah,
it out and then we'll put them in bags. The teachers were interested in
Okay. This is outside the national park as far as we know. Everything beyond that, is now outside the national park. So, and you're not going anywhere with off the island, so you'll be okay.
They thought it would be a really good research to have.
I think it would.
You already got yours? How easy was that? Maybe we should do 5. Then you can find 2 more. So keep it as your little pile. And then we'll sort them out and identify them.
I thought somebody would pick up that nice shiny round one down there. That looks like an egg. It's a dinosaur egg. There's a nice shiny one right there. That looks like an egg.
Excellent shine.
Right there, right? No. It's right there, near to her shoe. Dash. No, right. A little more. There you go. No. It's spotted. Right beside your right foot. There we go. No, spotted. Ah, there we go. Oh, I was just seeing the top of it.
Oh, you're gonna get wet.
I was seeing the top of it. I thought it was round like an egg.
This one's pretty up.
Maybe a little personal
Definitely.
pile. This one is cute.
You got them already. Nice work. That's something interesting.
Jeffrey, excuse me. Right, the correspondent. Bradley, excuse, I take you the video. Y'all blocking the way. Jeffrey! Oh, please. That SpongeBob is a square, and this is one.
Look at this one.
If I only had a brain.
I think you dropped something.
Got jokes, huh? What the hell? Man, we said snack. Sorry. We said snack. Dude over here eating 5-course meals.
Alright, so let's see if we can wrap the collection up in 5 minutes.
Okay, 5 more minutes.
5 more minutes.
2 hours later.
A world that looks like this. Flip that one over.
Brain,
That one. That one. How about you? Oh, you got one more. Just done that. Both of them.
yeah, man, same brain.
What if it is? No. That one's slightly different.
Slow.
Top of that one. It looks like brain? It sure does. Remember what we call them? Brain coral. Exactly. Yeah. How many people have one of these type of brain corals? Almost everybody, yeah. That's one right there. 1, 2. You've got 2 right there. You've got some. Right, this is one of the most common reef-building corals in all of the tropical Atlantic and Caribbean. Right? This is called, this long name, Pseudodiploria strigosa. It's a Latin name for, and all, humans have a Latin name. Scientific name. Every human is Homo sapien. Homo sapien. That's right. That's the Latin. Means wise ape or comes right down to it. Right? But that's a Latin name that we Biologists classify all living organisms with a binomial multiple. And so every one of these corals, when they're alive, of course, from the skeleton, has a Latin name. So that's the name. Big, crazy, long name like that. And this is often called the common brain coral. It usually, we're looking at is tiny little bits of brain coral. Normally brain coral grows in big lobes or hemispheres, like half of the Earth, big dome. These have been broken up. See, this is a broken side right here, and that's broken off here. So this is just a piece of it. One of the things you can tell is that one narrow ridge where the coral animal lives. Live in these kind of grooves with all those little lines in them. And the neat thing about these colonies is that, unlike you and I, where you can tell where you stop and somebody else begins, like right there, boom, we're different, right? We got a foot and a foot, and there's space between us. These coral polyps share tissue. They share part of their body with the individuals next to them. And that's why they can, when they're alive, they live in this entire kind of groove-like pattern. And as I was saying to the group on the other side, Pseudodiploria strigosa, the common brain coral, is very good at living on shifting sands. So it's one of the first corals that you can colonize an area and settle it. Grow as a hard lump. Maybe part of it dies off, and the part that dies off, another coral can grow on. Right? And so it provides like the foundations for a lot of these reefs. Now that's one. A lot of people have that one. Does anybody have one like this? It's a brain coral again, but the ridge is wider and it's got like a tiny little groove in that ridge. That's it. Right here. Right here. That's it right there. This is a beautiful one. This is the other one. This is the second most common brain coral. It doesn't have the pseudo part, but it changed the name of the other one to be Pseudodiploria. This is still called Diploria, and its last name is ridiculous. It's about this long. It's Labyrinthiformis. Okay?
Oh, forms in mazes.
But because the pattern looks like a maze, like a labyrinth, right? The one way you can tell them apart is the ridges are wider and there's a little groove that runs down the middle of them. Now, if it's a really water-worn piece, that groove might disappear a little bit, be harder to see. But in this one and in this one, it's pretty easy to see. There's that groove. See the groove right there? And the grooves right here? That's Labyrinthiformis. And it also is a pretty good pioneer species. It likes settling on soft sediment. And I guarantee you, there's a whole bunch of living ones right out there. That's the reef. And look at how close we are to it. All right, anybody find something? I'm pretty sure I saw something that looked like this. There's one there. Like a stick, yeah. But it's got little holes all over it. Yeah, there you go. There's one. This is one of the fastest growing corals in the world. One of two of the same genus, the same first name. There are two different species that are very common here. This one is called the staghorn coral, and its fancy name is Acropora cervicornis. Got the other one mixed up.
Yeah, we saw it, but we didn't pick that one up. Yeah.
Staghorn coral branches and branches and branches again. And sometimes it gets the oldest branches, the colony can be this big around. The small one, the youngest branches can be teeny tiny after. So that's why they call it a staghorn. It looks a little bit like the horns of a deer. Not really, but as far as corals go, that's about as close to deer antlers as you can get. When you look at the surface of this, you can see, where the coral animals were living in these grooves on the brain coral. They're a little more separated on this. They live in these tiny little holes. Look at the surface of that, and you'll see tiny little holes. That's where each one of the coral animals live. See those little holes here? And so there are hundreds of thousands of these little animals. They help make the skeleton that becomes their home. Right? They tend to like to live either in the slightly deeper waters in front of the reef where it breaks, the surge zone as it's called, or right behind it where the waves are a little less intense, sometimes called the back reef. There's a forereef, which is the part that's pointing out towards the open water where the big waves are. Right? And there's the top of the reef, the highest point is where all these waves are breaking. That's called the reef crest. And then the area towards us where there's still wave action, but it's not as intense. So this one likes to live in the back reef, not too far from the reef, but in the back reef, or deeper water in front of it. If anybody finds something like this, stick-like or finger-like, but it has branches. Aha! Yeah. Oh no, that's a cervicorn. That's the one we just saw. Looked like the Hey, there you go. There's one right there. Right? This is cervicornis tends to have these big, little pits, right where the coral is. This one, if you look at it, it's really hard to see the individual pits. They're very, very small and very shallow. And they're not deep. And so this is called the common finger groove, and its name is Porites. So it's the coral's so nice they named it twice.
All right.
This is also a coral that likes to live in the back reef area for the most part. Maybe tucked in between two really strong big corals. That's Porites. There's the stone.
Can I just say one thing?
Okay, sure.
Just to make sure that we all understand that corals are animals.
Yeah.
And that each hole here is where one individual animal lives. Even in those tiny little holes here, one animal, and the whole thing is a colony. It's like an apartment where a whole bunch of animals used to live.
Yeah. So this is one of the other really common reef builders in this area. And this is, as you can see, it's kind of club shaped. Yep, that's the one right there. Some are more mound shaped and massive. Some are more club shaped. That's it. That's it. Right? That's it. That's Orbicella. That's O-R-B. R-O-R-B-I-C-E-L-L-A.
Double L?
Yes. Annularis is the last name. And this is also, it used to be called Montastria. They changed the name, because there's some genetic differences from that and the other Montastrias. People, modern reef biologists who've kind of done, DNA studies. It's a little bit different, so they changed the genus. But this is one of the really common ones, and it forms in a lot of different environments. It's not as picky as some of the corals. It will live in a back reef environment. It will live in a reef-pressed environment. It will even live as a patch reef, not even anywhere near these, the breaking waves, way back in the interior of the flat platform. So that's the one there, Orbicella annularis.
So basically, round with circles.
Yeah, it often starts
circle
growing as a
circles.
kind of like a club, like this, growing up, and then there'll be clubs right next to it, and over time, sometimes they overlap one another, and then it becomes kind of a big mound of little clubs. There's another similar one. This one I bet you some people have. I see one from the distance right there. The one with the big holes.
This one?
Big rounded holes. Yeah, that one as well.
The trypophobia trigger.
See that one? That one as well. Notice how much bigger those holes are than these. They're kind of the same shape, but they're a little bit bigger, and there's a little bit more calcium carbonate in between each one of the coral holes. This is Montastria cavernosa. The name means star. And this is a pretty common coral as well. And you can go around finding lots of them. That doesn't mean we've seen them all. There are dozens of different varieties of coral that live off of that reef. These are just the most common, the ones you're more guaranteed to find when you go and either a modern reef, you go snorkeling off a modern reef, or you go, like we do, and look at the fossil reefs that are nearby. So, anybody have something that we didn't talk about? Ooh, yes. Wow. That one I don't know the species. That's a fabia. That's the genus fabia. I think it is. That's fragment. The smaller one's got that kind of color. Yes. Now this one's a little harder to define right off the bat. It's so young. This is what's sad, when this colony only had 1, 2, 3, 4 polyps before it was probably broken off and washed on shore. So it really never got a chance to grow into a big colony. Sad. But this is a tricky one because it looks like it might be either Leandrina, I think is probably the most likely, or actually a very young version of Pseudodiploria sligosa. That's another possibility. Really, I've never seen one quite that small, and I think it's oh my, yes indeed. Oh, that's really cool because it's kind of flattened instead of tubular in the cross section. All right, another weird brain-like coral, but it's not round like a brain. Right, it's got that same brain coral pattern on the surface, but the little valleys are a little bit shorter, and it's growing in a long column or like a pole or a post, and that's called Dendrogyra cylindriformis. And you can tell the difference between that and some of the other ring corals by the way the inside looks really, really porous. And of course, the shape of it is, in this case, a little flat, but a lot of times they're cylindrical in shape, and that's what the name is. Cylindriformis means form like the form of a cylinder.
And dendro, probably tree.
Why? I think, or a coral. That's the thing. Some of these you can see organized in a way that they're kind of khaki brown or a little bit green.
Hermit crab.
You know, you see various different kind of tan, honey colors. That's when the coral we know is alive.
Anisha.
Leave the coral. And as long as it doesn't kind of without a food source for more than a couple of weeks, they probably can come back. They don't like it when it's hot. So when it's really good temperature, the coral becomes white. And that's what's called a bleaching. And so really hot temperatures for long periods of time are really detrimental to coral reefs. We've had one of the hottest years on record as far as water temperatures. Water temperatures were in the 90s last year. South Florida, and it was pretty high in other areas. Oh, I got nutrients. I'll live here and I'll grow really fast while I have the option. And they grow on the surface of the coral, and that kills the shrimp. And then there's one other really bad thing is that we overfish and we tourists sometimes. I saw one on the beach over there. It was a turbid shell, or what's the other name of the turbid? West Indian. West Indian top shell. Yeah, the top shell. That really kind of it looks like a pointed hat. It's got kind of maroon white patterns around it. That's a big snail that loves eating the algae. And of course there are fish that eat the algae. But if we fish those fish out of existence and we pick up the shells because they're pretty and we put them into a collection or something, then the things that are keeping the algae at bay are no longer there. And so those are the major things that are killing. So whatever you can do to help your country preserve their corals, you should do it, because that's a very important environment.
Okay, so what do we do next? First of all, let's take a look at our collection from the number of corals that we piled up on individual pieces of paper. What can you tell about the makeup of the reef? Are all the corals equally represented? So notice, we just found one here. Look, we only found one here, one here. So it looks like that some corals are more common than others. So it could be because they grow more commonly here, or maybe they preserve more commonly here as pebbles on the beach. Okay, so David and others, how should we pack these? Do people want to add something to the collection, and then we'll put them in individual bags and give them to the teachers? We also have to carry them back. And then we should just take a quick look at the fossil and talk about...
field trip, remember to carry the power bank. Yeah, so I know that the trip is not ended as yet, but my phone battery died and therefore I couldn't record anymore. So technically this is where our video ends.
The students were able to connect their observations to important scientific questions about changing climate and sea levels. They were excited to be out in the field and had many questions for the visiting geologists who were delighted to share their knowledge and expertise with local teachers and students.
Alright, so if you have made it to the end of the video, thank you for staying with us and join us in the next video. And we'll see another field trip or some other interesting thing. Peace.